All right, let's solve this problem here. The question says the curve, this y of x here, is called a bullet nose curve. Find an equation of the tangent line to this curve at the point 1, 1. And then part B, illustrate part A by graphing the curve and the tangent line on the same screen. Okay, so I went ahead and put this function into an online grapher. I use Desmos, but you can use your graphing calculator or whatever you want. So there you go. There is the bullet nose curve. Yeah, so it definitely looks like the nose of a bullet right here. All right, and then at the point 1, 1, we want to find the equation of the tangent line. What is the equation of this line? Okay, how do you do that? How do we find the equation of this line? Equation of a line, you need 2 points or you need a point and a slope. We have a point, so now we just need a slope or another point. Well, we can use the derivative to get the slope, so then we'll have a point and a slope. The slope of the tangent line to this curve, we can find in general using the derivative for any x using the derivative. Then we just plug in x is equal to 1. We get the slope, then we'll have a point and a slope. We can find the equation of the tangent line, and then once we have that equation, I'll input that into Desmos as well, and that will be part B. Okay? So we need to find, we have a point. The equation of the tangent line, we have a point. Now we just need a slope. The slope of this curve at any point x, or the slope of the tangent line to the curve at any point x is the derivative, is dy dx. So we just need to take this derivative. So how do we take the derivative? We're going to use the quotient rule here. Derivative of the top times the bottom, right, minus derivative of the bottom times the top. So how do we take the derivative of the top? The derivative of the absolute value? Well, so like the absolute value of x, we know it looks like this. It's not differentiable at that kink point, because the derivative coming from the left and coming from, or the slope coming from the left and coming from the right are different. But anywhere away from that kink point, the curve, you can take the derivative. The curve is differentiable. Well, we're away from the kink point, right? We're trying to find the equation of the tangent line, not at the kink point of the bullet nose curve. We're not trying to find the equation of the tangent line here. We're away from that point. So what we need to do is just realize that we can remove the absolute value symbol based on where we know we need to evaluate this derivative. Okay, we're at 1, 1, x is positive, right? So we can just say we're trying to take dy, or no, we're taking, so d dx of, just remove the absolute value symbol, right? Because we know that x, the portion of the curve that we're evaluating, x is positive. If we were over here, we would say, to remove the absolute value, we would say we'd remove the absolute value signs and then just put a minus sign out front. If we were trying to find the slope of the tangent line here. So x over okay, so now we just need to take this derivative. Let's use the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom. Okay, so we need to use the chain rule here. So the derivative of the square root of something is 1 over 2 square root of that something. Okay, times the derivative of that something. Derivative of 2 minus x squared is minus 2x. Okay, so the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared, so just 2 minus x squared. Okay, so let's simplify. We've got, so 2 minus, so this turns into a plus actually, so x squared over so let's combine these two. So we get, so multiply this times the root of 2 minus x squared over the root of 2 minus x squared, you get 2 minus x squared and then plus x squared over, okay, so these cancel. So what do we have? We've got 2 over root 2 minus x squared times 1 over 2 minus x squared. So we can combine, this is 2 minus x squared to the first, this is 2 minus x squared to the 1/2, so we've got 2 minus x squared to the 1/2 plus 1 is 3/2. Yeah, there we go. So this is dy dx. That is our derivative. The derivative for this region of the curve. Not the derivative for the entire curve, just this region here to the right of the kink. Okay, so what are we trying to do? We've got a point, and we're trying to find the slope at x is equal to 1. So what is dy dx at x is equal to 1? Is equal to, so 2 minus 1 squared is 1. 1 to the 3/2 is 1. So 2. This is your m. Okay? So m is equal to 2. Okay, so now just algebra. We have a point and a slope. How do we write the equation of a line if we have a point and a slope? Y minus y1 is equal to m times x minus x1. Okay? So now just distribute and put it into the y equals mx plus b form. So y minus 1 is equal to 2x minus 2. Y is equal to 2x, so add 1 to both sides, minus 2 plus 1, minus 1. Okay, that is the equation of the tangent line to this curve at x is equal to 1, or at the point 1, 1. So that's part A. Okay, part B, illustrate part A by graphing the curve and the tangent line on the same screen. So all I did was went to Desmos. All it's doing is just like a graphing calculator. I just type in, I had this function typed in, and that's when I had the original curve. I just added an extra equation to plot on the same graph, and I just put y is equal to 2x minus 1. That's it. And it gave me this. There you go. Simple as that.